Some of the students, you are not serious. So this morning 8 to 12, how you are sitting in regular classes, sit like that, be serious. Definitely very useful to you. And because of this COVID-19 session, how many days still it is, we don't know. Maybe we'll announce your first PUC results after May 3rd. Many of you are calling me. So after May 3rd, you can expect your first PUC results. And I'm expecting the classes also after June 2nd week. Maybe up to that we will not get permission from the PU board to run the regular classes. So another 2 months, these sessions will be very useful to you. 2 months, if you are lazy means, definitely it will affect your result. Everyone, you know the importance of the second PUC. Very crucial period for you, PUC, KSET, NEET and JEE mains. So if you are utilizing these classes through the textbooks and practice the once again, and even we are releasing the videos in YouTube. So definitely, I hope that everyone you are utilizing all these services. Any of your friends did not get the link means, just please help them. If you are having your WhatsApp number and student name and send me, we'll link you. It's only 1 day completed. It takes, these classes will go another 2 months definitely. So all the students, you have to be linked with these classes, regular classes, and using the for revision YouTube classes. And to run this session, our best management and best faculty, we have taken a lot of risk. So I'm requesting all the parents and students utilizing these classes properly. And who worked for this one, just I will introduce you, who helped me a lot to run these classes, especially newly appointed lecturer chemistry, Mr. Kumar Reddy sir, come here sir. Sir, March 18th, he joined in our college. Earlier, he worked in Chaitanya and Nandi College. He is a senior faculty. He was appointed as lecturer in mathematics and lecturer in chemistry and coordinator for admissions. So he has taken a lot of risk to run these classes. My heartful thanks, sir, on the behalf of all the students for you and management and faculty. And next technical team, Santosh sir, our lecturer in computer science, come here. You know very well our lecturer, computer science lecturer Santosh sir, and our computer operator Keshav sir, come here sir. So to come to the college also very difficult for us. They are taking a lot of risk to come to the college and to run this session. So I hope that, come here, all of you will utilizing these classes, just understanding the risk which we are taking here. Definitely we are ready to help you for all the students. So PCMB computer science classes are not there. After coming to the college, computer science classes will be there. Time will be enough for us. Even what we are running these classes, definitely we will revise in regular classes. But these 2 months you should not be lazy. If you are lazy these 2 months, definitely you will forget all the subjects. So that's why we are running these online classes by taking a lot of risk. Once again, good morning to everyone. Thank you. Thank you. Dear students, yesterday we recorded only physics, chemistry and biology. Today we'll record mathematics also, we'll release in YouTube. So YouTube channel will be very useful to you for revising those classes once again. Every day 4 hours we are teaching to you. At least from your side also another 4 hours work it is there means definitely this session will go very truthfully. So what I am expecting June second week, if the situation is good. If situation is good, we can expect the classes after June second week. If situation is not good, where it goes, we don't know. So that's why, but for you, as a student, compulsory you have to write the PUC exams, you have to write KSET exam, you have to write NEET exam, you have to write JEE mains exams. So it is compulsory for you. So good result is important for you. So don't waste your time. Utilizing these classes, textbooks, compulsory. Immediately try to get the textbooks. After May 3rd, maybe they will open the book stalls. Before that one, we have given link to you downloading that one and practicing second PUC. Or any of you, if your neighbors and friends are there, take those books and practice this session. Yesterday we discussed inverse trigonometrical functions. Inverse trigonometrical functions. Trigonometrical functions. Just I introduced the topic for you yesterday. Today once again I will revise this topic. From this topic in PUC you will get one 1-mark problem, two 2-mark problems, one 3-mark problems. So totally how many marks you will get? 8 marks. In PUC, KSET you will get 2 questions. And one important topic, basics are so important. Through this small topic, we can revise all the basics of trigonometry and functions. So yesterday, first we discussed about function. What is a function? Once again, just I will revise you. 2 minutes, just yesterday session, I will revise you. Function means, just listen to me. A relation f maps from A to B is said to be a function if each element of A, associates uniquely with the elements of B. This is function definition. A is called domain, B is called codomain, set of images ABC is called range, image of 1 A, image of 2 B, image of 3 C, 3 image of A1, 3 image of B2, 3 image of C3. Yesterday we discussed this one. Function, domain, codomain, next image, pre-image, range. These are the important words in a function. Next we discussed one function. One function. Types of functions. A function, it should be a function first. A function f maps from A to B is said to be a 1 if each element of A are having different images in B. All the elements of A, 1, 2, 3, A, B, C, D. See this one. Different elements of A are having different images in B. That's all. It is one function. Next we discussed about onto function. What is meant by onto function? It should be a function. A function. Here I am telling it's a function. A function f maps from A to B is said to be onto if codomain is equal to range. Codomain of f is equal to range, or a function f maps from A to B is said to be onto if every element of B is having pre-image in A. That is the definition of onto. Next we discussed about object bisector function. Bisector function. A function f maps from A to B is said to be a bisector if it is 1 and onto. If it is 1 and onto, bisector function. To define the inverse function, compulsory we require the first condition is it should be a bisector function. It should be a bisector function. Then only we can define the inverse function. What is inverse function? Just listen to me. Inverse function. Inverse function. If possible, note down the notes for this one. From this concept onwards, your second PSC syllabus will start. Inverse function. A function, if f maps from A to B, if a function f maps from A to B is bisector, if a function f maps from A to B is bisector, then inverse of f is defined, and f inverse is a function which maps from B to A, See this one here. We have taken one function, bisector function. How to define the f inverse? F inverse is maps from B to A. Just reverse. Take the codomain as a ray, codomain as domain, domain as codomain. This is a simple example to define the inverse function. It should be f maps from A to B is a bisector. Then f inverse is defined. It is a function from B to A. Clearly, we'll discuss about all these things in a functions topic. This year we have relations and functions topic. There we'll discuss. Even yesterday we discussed about trigonometrical functions. See the trigonometrical functions we discussed. We discussed about the domain and range of the trigonometrical functions. Just once again, just I will give the table. Listen to me. If y is equal to sin x function, its domain value. By using the definitions yesterday we discussed it. What is its domain? R. What is its range? Range closed interval -1 to 1. Just I am reminding the basics. And y is equal to cos x. What is its domain? R. And closed interval -1 to 1. Next, y is equal to tan x. Domain is r minus of x such that x is equal to odd multiples of pi by 2, where n belongs to I. And what is its range? R. This table is important for you. And y is equal to cot x. What is its domain? R minus of x such that x is equal to n prime. Yesterday we discussed how it is. And what is its range? R. And what is the domain of y is equal to secant x? Secant x is a reciprocal function for cos x. R minus of secant x definition is 1 by cos x. Cos x, when it is not defined, cos pi by 2 0, when denominator is 0. So x such that x is equal to odd multiples of pi by 2. We have to eliminate this set. N belongs to I. What is its range? R minus of -1 to 1. Because cos x strictly lies between -1 to 1. So the secant x does not lie between -1 to 1. Next, y is equal to cosecant x. Its domain is r minus of 1 by sin x. Sin 0 0. So it is not defined. So x is such that x is equal to n pi, where n belongs to I. Here the range is r minus of -1 to 1. In yesterday's session we discussed up to here. Now coming to this one. Inverse trigonometrical functions. To define the inverse trigonometrical functions, what is the condition we are expecting? Sin x. First we discuss about the inverse function of sin. Y is equal to sin x. What is its domain? R. Sin x domain is R. Its range is -1 to 1. Is generally sin x function is a bisector. See the This one. What is sine 0 value? 0. So through sine function, it is related to 0. What is sine phi value? That is also 0. What is sine 2 phi value? That is also 0. So different elements of the domain are having same image. So it is not 1, 1. It is not 1, 1 means it is not bisector. It is not bisector means inverse function of the sine is not defined generally. But how to define afterwards we'll discuss. So note, important note is generally trigonometrical functions are not bisector. Generally trigonometrical functions are not bisector. So inverse functions for trigonometrical functions are not defined. Keeping in your mind this point always. Because even it is a small topic, conditions are more, 100 conditions are there. That's why PUC very easy for you. But while going to objective questions, while preparing the questions, compulsorily we have to follow the conditions. Now see. So when we can define the inverse functions. The same here, we cannot restrict the ranges, we will restrict the domain. For some restricted values, for example, see this one. Put the heading bisect two trigonometrical functions. This is important table for you. Bisect two trigonometrical functions. Bisect two trigonometrical functions. Bisect two trigonometrical functions. From here onwards, your second piece of syllabus will start. Bisect two trigonometrical functions. See the y is equal to sin x. When it will be the bisector? If we are restricting the domain values, I am restricting. We are diminishing the domain values. I am taking closed interval minus pi by 2 to plus pi by 2. Range closed interval minus 1 to 1. When sin x is defined with the domain closed interval minus pi by 2 to plus pi by 2 to minus 1 to 1, it is bisector. So we can define the inverse function. Next, note on this. First note on this table. Y is equal to cos x. Y is equal to cos x. Its restricted domain is 0 to pi. When we are taking the domain as 0 to pi, it will obey the two conditions, 1, 1 and on two conditions. The range is minus 1 to 1. Next, y is equal to tan x. Open interval minus pi by 2 to plus pi by 2. The range is R1. There is no change in range values. Please observe that point. Next, y is equal to cot x. Y is equal to cot x. Open 0 to pi because cot 0 undefined, cot pi undefined. So open 0 to pi, open interval. The range is R1. Next, y is equal to secant x. Y is equal to secant x. Secant x, series secant x. Secant x means 1 by cos x. 1 by cos x means 1 by cos pi by 2 undefined value. So take the cos x domain only. Take the cos x domain only, but eliminating the pi by 2. Set pi by 2. Single term set it is. Eliminating. This is infinite set. 0 to pi means infinite set it is. We are eliminating one element, pi by 2. Same as cos x domain, but 1 by cos x, secant x definition is 1 by cos x. 1 by cos pi by 2 means 1 by cos pi by 2 means 1 by 0, undefined. So in the domain value, we should not take the pi by 2. The range is same. R minus of minus 1 to 1. Now y is equal to cosecant x. Y is equal to cosecant x. Here same as cosecant x is the reciprocal function for sin x. So closed interval minus pi by 2. Cosecant x means 1 by sin x, 1 by sin 0, 1 by 0 undefined quantity. So eliminating the element 0. Range is R minus of minus 1 to 1. So we have 6 trigonometrical functions. Generally, original trigonometrical functions are not bisective. So we define the bisective trigonometrical functions to define the inverse trigonometrical functions. Now come to the topic. First I will give the domain and range of inverse trigonometrical functions. Then we will define each function separately. Now on one more important table. Inverse trigonometrical functions. Inverse trigonometrical functions. Inverse trigonometrical functions. See, y is equal to sin x means inverse function can be taken as x is equal to sin inverse of y. This is the definition. If f of x is equal to y, if inverse function is defined means x is equal to f inverse of y. So y is equal to sin x is a bisective function for this restricted domain and up to this range. So inverse function is defined. Now tell me its domain. Domain and range. Based on this table, you will get the first one mark problem. Domain and range, you have to practice. Range is also called as principal value branch. Principal value, main value, principal value branch. Because while in PUC examinations, when they are asking the questions, they will ask like this, principal value branch. So x is equal to sin inverse of y. Tell me its domain. Range becomes domain, domain becomes a range. That's all. When you know the bisective functions, what is its domain now? Minus 1 to 1. Minus 1 to 1. What is this range? Domain becomes range. Minus 1 to minus pi by 2 to plus pi by 2. Once again we'll discuss in the definition. This is just not on the table. We'll discuss the 6 definitions separately. Second one, x is equal to cos inverse of y. What is its domain? Now, closed interval minus 1 to 1. What is its range? 0 to pi. 0 to pi range. Like this, complete the remaining. X is equal to tan inverse of y. Inverse function. So what is its domain? R. What is its range? Open minus pi by 2 to plus pi by 2. So these are the main 3 functions. Remaining 3. X is equal to cot inverse of y. X is equal to cot inverse of y. So what is its domain R? What is its range? Range 0 to pi. So x is equal to secant inverse of y. X is equal to secant inverse of y. What is its domain? R minus of open interval minus 1 to 1. Open interval minus 1 to 1. What is its range? Closed interval 0 to pi minus of pi by 2. Set pi by 2. We have elements. Next, x is equal to cosecant inverse of y. Cosecant inverse of y. R minus of minus 1 to 1. So what is its range? Closed interval minus pi by 2 to plus pi by 2, but we have to eliminate the element 0. So these are the bisector trigonometrical functions. So we can define the inverse trigonometrical functions by using this domain and range. So dear students, practice all the three tables. Trigonometrical functions, domain and range, first table. Second table, bisector trigonometrical functions, practice the table. And next practice this table, inverse trigonometrical functions. Based on this table, you will get first 1 mark problem. Based on this table only, either they will ask domain or range. Sometimes they will ask principal value branch. What is the principal value branch of cos inverse of y? What is the principal value? Closed interval 0 to pi. So you can create your own questions. How many questions you can create here? 6 based on domain, 6 based on range, 12 questions. Question format. Maybe they will ask principal value branch. So 18 types of questions you can form on this table. So practice that one also. How to frame the question if you are practicing, definitely easily you can face the KSET or NEET or JEE mains question. Mainly you will struggle on it. You have to face the new question. In PUC, direct question from textbook. But in the NEET, JEE mains and KSET, we have to face the new question. New question, but concept is the same. That's why, as a student, if you are practicing how they are framing the questions, keep one eye on how to frame the question. Practice the question also. Just you will practice the solutions and formulas. No, how to frame the question by using the given concept. If you are having this confidence, you can link the concepts. Easily you can crack the JEE mains or KSET. Just remind yourself. Just revise the tables. We'll define the functions now. Now done. First one. Inverse of the sine function. First definition. Inverse of the sine function. Inverse of the sine function. Inverse of the sine function. It is denoted by sine inverse of x. Sine inverse of x denoted by r arc sine x. Arc sine x. In some textbooks, sine inverse of x they are following. In some textbooks, arc sine x. Both are same. Arc sine x or sine inverse of x. Inverse of the sine function. The name of the function is inverse of the sine function. It is denoted by sine inverse of x or arc sine x. Be careful. Generally, trigonometrical rules will violate these rules. Inverse functions rules are completely different. You should have that point in your mind. Now listen to me. Inverse sine function. We discussed already. To define any inverse function, what we require? We require bisector function. So let's first We'll take the bisective function. Let, here I'm taking x is equal to sine y. Because this is main topic for you, I'm changing x and y. X is equal to sine y is a bisective function. Is a bisective function. Is a bisective function from already you know. Is a bisective function from closed interval minus pi by 2 to plus pi by 2 to closed interval minus 1 to 1. When it is bisective, define those conditions. Already you know. We have given in table. Let x is equal to sine y is a bisective function from closed interval minus pi by 2 to pi by 2 to closed interval minus 1 to 1. Then inverse of sine function. Inverse of the sine function is defined and sine inverse x is a function from, it is a function from what is its domain? Closed interval minus 1 to 1 to closed interval minus pi by 2 to pi by 2. Just bisective function we defined, change the domain as a range and the range as a domain. So is defined, and sine inverse of x is a function from minus 1 to 1 to minus pi by 2 to pi by 2. That's all. This is the inverse of the sine function. And we'll discuss some points, key points. See the observation, sine inverse of x. What we have to take x? Always lies between, that value always lies between closed interval minus 1 to 1. See how to form the questions here. I am asking you, what is sine inverse of 1? How to find that value, sine inverse of 1 value? Sine inverse of 1. See this one. Let sine inverse of 1 is a theta. So 1 is equal to sine theta. So theta must be a pi by 2. So sine inverse of 1 is pi by 2. We will use the definition, inverse function definition. Next is some standard angles we'll practice. What are the standard angles for sine function? See this one. First term, we'll define the sine inverse of 0. What is sine inverse of 0 value? 0, because sine 0 is 0. Next, sine inverse of 1 by 2 value. What is sine inverse of 1 by 2 value? When sine theta will be 1 by 2? When sine theta will be 1 by 2? For sine, pi by 6. So sine inverse of 1 by 2 is pi by 6. Or else, listen to me. How to define these values? Still easy procedure is, note down these examples. Some examples. Sine 0 is 0. We know this one very clearly. So 0 is equal to sine inverse of 0. So what is sine inverse of 0 value? You have to practice. This is main value here. Sine inverse of 0 is 0. Example 2. What is sine pi by 6? Sine 30 degrees value 1 by 2. So sending the sine function to right side. So pi by 6 is equal to sine inverse of 1 by 2. So what is sine inverse of 1 by 2 value? Pi by 6. Important examples. You will have questions based on this one only. Next, guess the next question. Sine pi by 4 value. What is sine pi by 4 value? It is 1 by root 2. So That implies pi by 4 is equal to sine inverse of 1 by root 2. This is example 3. Example 4. Sine of pi by 3 value. What is sine of pi by 3 value? Root 3 by 2. So in reverse, pi by 3 is equal to sine inverse of root 3 by 2. Last standard example. Example 5. We know sine pi by 2 value is 1. So pi by 2 is equal to sine inverse of 1. So these are the important standard values. About negative values, after some rules we discuss about negative values also. Is it clear how to find sine inverse of 0? Practice this one. 0. Sine inverse of 1 by 2, pi by 6. Sine inverse of 1 by root 2, pi by 3. Sine inverse of 1, pi by 2. But always x value. What is the domain of this function? Closed interval minus 1. What is its range? Closed minus pi by 2 to plus pi by 2. So compulsory we have to follow these conditions. If I am asking you one question, tell me the answer. Sine inverse of root 2. What is root 2 value? More than 1. More than 1 means more than 1 or less than minus 1 means sine inverse function is not defined. Don't ask me wrong questions, sir. Okay. Always the condition must be, x value must be in between minus 1 and plus 1 only. Then only we can define. If you are taking sine inverse of root 3, not defined. Okay. So value must be, maximum value is 1, minimum value is minus 1. X value we have to take. That is the domain. Range values. See the range values. What type of values we are getting here? Sine inverse of 0, 0 degrees. Sine inverse of 1 by 2, pi by 6. It is angle. Sine inverse of 1 by root 2, pi by 4. It is an angle. Sine inverse of root 3 by 2, pi by 3. It is an angle. Sine inverse of 1 pi by 2, it is an angle. So we can generalize the one condition. The value of inverse trigonometrical function is always an angle. The value of inverse trigonometrical functions is always an angle. Note down, important notes. The value of inverse trigonometrical functions is always an angle. Key points note down. That is note 1. The value of inverse trigonometrical function is always an angle. That is first point. See the second point. Sine inverse of x is not equal to 1 by sine x. Generally, you are having that habit to a power minus 1 means 1 by a, x power minus 1 means 1 by x you will write. But this is function. This is function. Sine inverse of x is a function. It is not 1 by sine x. Sine inverse of x is not equal to 1 by sine x. So dear students, is it clear about sine inverse of x function? Now by using this knowledge, you can define the remaining 5 inverse functions. I will define the other 2 for you, cos inverse of x and the tan inverse of x. Remaining 3 you can practice in the same way. Now the second one, inverse of the cosine function. Inverse of the cosine function. Second definition, inverse of cosine function. Inverse of cosine function. Inverse of the cosine function. It is denoted by cos inverse of x or arc cos x. Here only note down it's the domain and range already given for you in table. It is a function from -1 to 1 to closed interval 0 to pi. Then only it is bisected. That is the heading. Inverse of the cosine function. It is denoted by cos inverse of x or arc cos x. Its domain is closed interval -1 to 1 to 0 to pi. Now listen. Same. Let x is equal to cos y is a bisective function. Is a bisective function. Is a bisective function. Is a bisective function from closed interval 0 to pi to closed interval -1 to 1. First define the bisective function for cos. Then inverse of the cosine function is defined. Inverse of cosine function. Cosine function is defined. And cos inverse of x is a function from what is its domain? Closed interval -1 to 1 to 0 to pi. This is the definition of cosine function. Inverse of the cosine function definition. And how to find the values here? As we discussed for cosine, this one, what is its domain? Domain is closed interval -1 to 1. So x values we have to take in between -1 to 1 only. We will now take the examples. Just to complete this definition, let x is equal to cos y is a bisective function from 0 to pi to closed interval 0 to pi to closed interval -1 to 1. Then inverse of the cosine function is defined, and cos inverse of x is a function from -1 to 1 to 0 to pi. See the examples. Important examples. First one. We know cos pi by 2 value. What is cos pi by 2 value? 0. Applying the inverse function definition. Inverse function, when it is applicable, means for these conditions only. So pi by 2 lies between 0 to pi. We can apply. So pi by 2 is equal to cos inverse of 0. Don't get confusion. Cos inverse of 0 value, pi by 2. Sin inverse of 0 value, 0. The example 2. Cos pi by 6 is equal to root 3 by 2. Cos pi by 6 value, cos 30 degrees value, root 3 by 2, we know. So, by inverse function definition, cos inverse of root 3 by 2 value. What is cos inverse of root 3 by 2 value? Pi by 6. Practice is required. We have to practice many times, because generally trigonometrical you practice it very well in first PUC. Those values will disturb your mind. Inverse functions values are different. Example 3. Guess the next example. Cos. Very good. Cos pi by 4 is 1 by root 2. So cos inverse of pi by 4 is equal to, sending this function to right side, cos Inverse of 1 by root 2. Example 4. Cos pi by 3 value 1 by 2. So reverse. Pi by 3 is equal to cos inverse of 1 by 2. Cos inverse of 1 by 2 is pi by 3. Sin inverse of 1 by 2 value is pi by 6. Don't get confusion. Last example, guess the last example here. Cos 0 value 1. So 0 is equal to cos inverse of 1. Cos inverse of 1 value 0. Negative values we'll discuss. One property is there. After discussing the properties, we'll discuss the negative values also. So is it clear, dear students? One more function I will define for you. Inverse of the tan function. Third one. Inverse of the tan function. Inverse of the tan function. It is denoted by tan inverse of x or arc tan x or arc tan x. Arc tan x. We discussed already. What is its domain? Domain is R. What is its range? Range open minus pi by 2 to pi by 2. Domain is R, x value. Domain means tan inverse of x, x value. Range means y value. Open minus pi by 2 to plus pi by 2. So try to define yourself. Now you are familiar already with two definitions. I will finish it. Remaining three, do the homework. First we have to define the let x is equal to tan y is a bisective function. Is a bisective function. Is a bisective function from. Is a bisective function from open minus pi by 2 to pi by 2 to x is equal to tan y is a bisective function. First we have to define the bisective function. Then inverse of the tan. Inverse of tan. Inverse of the tan is defined. Is defined under tan inverse of x is a function from just R2 open interval minus pi by 2 to pi by 2. So what is the domain of the tan inverse of x? X value we can take any real numbers, and that means real line up to plus infinity, minus infinity. R element, its domain. X values you can take, x belongs to R. Any value we can take. We'll practice some standard values. You guess the example, first example here. Guess the first example. Example 1, tan 0, 0. Tan 0 value 0. So tan inverse of 0 value 0. Example 2. Next standard value, tan pi by 6 value. What is tan pi by 6 value? 1 by root 3. 1 by root 3. So that implies, what is tan inverse of 1 by root 3 value? Practice this one. Tan inverse of 1 by root 3, pi by 6. So example 3. Tan of pi by 4 value 1. That implies pi by 4 is equal to tan inverse of 1. Tan inverse of 1. Okay, guess the next example. One more example is there. Example 4. Example 4. Tan of pi by 3 value root 3. Tan of pi by 3 value root 3. So pi by 3 is equal to tan inverse of root 3. So today we discussed the definitions of three inverse functions. One is sin inverse of x, cos inverse of x, tan inverse of x. Remaining three homework for you. Practice like this one is practice the remaining three definitions. Tomorrow we'll discuss about properties of inverse trigonometrical functions. So based on this class, I will ask some simple questions. Right? How they will ask the questions for you. Questions. How you will get based on this. You see how they will ask you the question. First one. First question. Domain of cos inverse of x. Write the domain of cos inverse of x. What is the answer? Answer. Domain of cos inverse of x. Second question. Range of sin inverse of x. Range of sin inverse of x. Write your answers. You see questions already they asked these questions. One more question. Third question. Principal value of the branch tan inverse of x. See the three question formats. First, domain of the cos inverse of x. What is its domain? Closed interval minus 1 to 1. What is the range of the sin inverse of x? Range closed interval minus pi by 2 to plus pi by 2. If you are practicing the table perfectly, answering these questions very easy. Principal value of the branch is nothing but range of the tan inverse of x. What is the range of the tan inverse of x? Open minus pi by 2 to plus pi by 2. One more question. Principal value of sin inverse of root 3 by 2. Principal value of sin inverse of root 3 by 2. Principal value of sin inverse of root 3 by 2. Tell me the answer. Already we practiced. That is, what is the answer? Sin inverse of root 3 by 2 value, pi by 3. Principal value is nothing but range. The value of principal value of the range of, they will ask the questions like this. Okay, thank you. Tomorrow we'll meet. Tomorrow we'll discuss just about the properties of the inverse trigonometrical functions. Totally, in this small chapter you have 100 formulae. Totally 9 sets, 9 into 6, almost all. Theory formulas are there. We'll discuss about that one next in important session. So if possible, write the notes. Otherwise, follow the textbook. In textbook, all these things are there. Okay, thank you. Thank you. 9 to